right, the warm-up at the top of your paper. We're actually going to wait to do that until the end, okay? Because I want to do something special with it. Special. Real special. There it is. All right, so we're actually going to do the warm-up last, so wait on that. Yesterday, we had logs. We brought in exponentials or bases, right, to cancel them out. Today, I have exponentials, so I'm going to bring in a log to cancel them out. On the left-hand side, the log had what base? I brought in a log with a base of 4, right? Because my exponential had a base of 4. Remember, to do it to one side, I gotta do it to the other, so they balance out. This side they cancel, so x minus 1 is left over. And then evaluate log 4 of 5. So that change of base means log 5 divided by log 4. That's where the 1.16 came from. And then last step is just to add 1 to both sides, and that's where we get 2.16. All right? So let's do this one next to it. I have log with an exponent of negative x equals 21. What log am I going to bring? A log with a base of 7. So log 7 of 7 to the negative x equals log 7 of 21. Okay? This side cancels. We have just negative x left over. The other side is not 3. Okay? Lots of people will say that. It is not 3. 7 raised to what power is 21? That's what we're finding. So do log 21 divided by log 7. 1.56. All right. My x is not by itself. We're going to have to divide by negative 1. So we end up with x is equal to negative 1.56. Okay. Before I circle it, am I allowed to have negatives today? Are there any rules about having negative exponents? Are they allowed to be there? Yeah. Yes, you can absolutely. We've worked with them before. Yes, you can have negative exponents. So that's not a restriction I have to worry about today. Yesterday, it was a no-go. You could not do log of a negative number. Today, though, if I have a negative exponent, you're fine. So less rules to worry about today. I don't have to condense like I did yesterday. Pretty easy peasy. The one thing you got to make sure, though, with your logs is make sure that the exponential is by itself before you bring a log in. Like if this first one had like a 2 plus in front of it, we would have had to move the 2 before I did the log stuff. Okay? Even if it was a negative 7, I would have had to move the negative before I bring in the log. Okay? So just make sure that is cleared for us. In our note that's cleared, your homework, I'll show you a couple where you got to move stuff, and your warm-ups is another kind of like bonus level of how to work it out also. You good? Questions? Yes.
I know you're already supposed to know this, but like the log, how did you get 1.56 on the calculator again? Did you just plug it in?
Log 21 divided by log 7. Yeah, I'm evaluating the log. You're good.
Okay, yeah.
We're evaluating the log. I've been asked that every class period, so you are not alone. I'm sure other people in here were thinking the same thing. Where the heck did she get that from? Okay. So down here, let's do number 17. I have 8 raised to the x plus 4 equals 137. Is the exponential by itself? Yep, so we can go ahead and bring a log in. What base will the log have? A base of 8. All right. On the left-hand side, those cancel out. We're left with just an x plus 4. I have to evaluate log base 8 of 137. 2.37. Can someone confirm? Confirmed. 2.36. 6 repeating. Okay. All right, now what? Now we subtract 4. So I have x is equal to negative, what? It's negative 1 point something. Good, like that. And our negative's okay for answers today. Bless you.
So why did we put cancel the 8 on both sides?
What do you mean?
Don't you do the thing where you put the 8 in front and then cancel out?
I did. I brought log 8 to both sides. That way I could eliminate the base and the exponent can fall down. When I do log 8 of the other side, I have to do log 8 of 137. So I have to evaluate that logarithm that I've made. All right, part B. Is anything being added or multiplied to the exponential? No. So what log are we going to bring in? Log at the base of 5. If we do it to one side, we have to do it to the other. So both sides get a log at the base of 5. Log 5 of 5 cancels. We're left with 2x. My other side, log 5 of 1250. Again, change of base tells me to do log of 1250. Whoop, there we go. Divide by log of 5. What does that give us? 4.43? Yes? And what's next? Divide by 2, we get x equals. Good. What's nice with these is you can plug them back in and check. Questions on those two? I want you to try the bottom two. I want you to try the bottom two. So 18, A and B. All right, check your answers with mine. For A, you should have gotten x equals 0.575. Some of you have 0.58. The more decimal places you have, guys, the less rounding error you have. The more you round an answer, the less accurate it becomes each time you round it. Okay? So if you can go 3, 4 places out, that's actually better for your answer. Part B, you should get negative 2.52. Part B? Yep. All right, so B, so we had to bring in a log of base 2 to both sides first. It's thinking. Hold on a second. There we go. Log of a base 2 to both sides. Okay, so here they cancel. Here I have negative 3x minus 1 equals, where is it, 6.5? Yeah. 6.55. Still with me? Right? From here, you add 1, divide by negative 3. Because you can't. Solving for x, you have to add 1 first. Yeah. Gotta add that 1 first. Then divide by negative 3. All right, any other questions? You ready to level up? What's up, Adam?
About the decimal places, are you gonna be so sig figs don't matter?
Yeah, that's what I was just thinking about.
We don't do sig figs.
And I was like, we're not in chemistry.
Our science teacher, oh, it's wrong if you sig figs.
Well, in chemistry, that's how they do it. So do it that way in chemistry. Don't do it in here, because I'm not gonna know what you're talking about.
That's why I keep getting them wrong. I keep doing the sig figs.
No sig figs in here.
And I'm doing negative 2, and I have to run that to negative 3, since there was only one number at the beginning.
Gotcha. Alright, guys. We're going to level up with the warm-up. We're going to do number 2 and number 3. Okay? There's lots of ways to do it. You could, like, change the bases and exponents and do it that certain way. I'm going to use logs to solve because now we know how. So, number 2 at the top. Okay? And it's also going to include a different log property that we haven't used yet that I want you to be able to see how to use it. So, we have 3 raised to the 2x is equal to 27 squared, right?
Right.
That is number 2, right? I see 2 bases, I see 2 exponents. What log are we going to bring in?
3.
Why is it log base 3?
Because it's the front.
Not because it has the x in the exponent. All right, so I'm going to do log base 3 to both sides. All right, so my 3's do cancel to leave me with 2x. My other side, here's the level up. There is a power still, right? So I'm going to use my power property. I'm going to move the 2 in front before I evaluate. Okay, what is log 3 of 27? It's 3.
So that's 3 times 2.
Yeah, so then it just changes to 2x equals 6. So x just equals 3.
Wait, what?
Okay, so what's happening here is we have another power on the other side. After we've canceled out the logs, we still have a power existing on the right-hand side. Move the power to the front of your log using your power property, then evaluate, and then multiply. Okay? What? Yes, you, Langston. Well, because it's not the same thing. 27 times 2? I mean, you could, but my goal here is to show you how to use the power property. So, not with what I'm trying to get you to do right now, which is the power property. Because you can't do it in the next one. But you can do the same thing I just did in the next one. Does that make sense? So what you did won't work every time. My way works every time. So number 3, we have 4 raised to the x minus 3. Uh-oh. They do. 16, 2x minus 2. Yes, they do both have an x this time. So it doesn't really matter what the base is of my log. It doesn't matter which one you pick. You could have log 4 or log 16. Okay? I'm going to pick log 4, personally. Okay? What you cannot do log 4 on this side. This is what you do not do. And then a log 16 on this side. You really want to, but you cannot do that. They have to either both be base 4 or both be a base of 16. I'm going to make them both be a base of 4. Left side cancels. I have x minus 3. I'm going to do my power property. So I'm going to bring 2x. 2x minus 2 out front. Multiply that by log 4 of 16. What is log 4 of 16? It is 2. So we get x minus 3 equals 2x minus 2 times 2. Simplify the right-hand side to give me 4x minus 4. And then we just solve for x. I'm going to subtract x over to give me 3x on this side. I'm going to add 4 over here to give me a 1. Now I'm going to divide. I get 1/3 equals x. Right. And again, you could plug them back into the original to make sure that it does work for you. All right, so this is a way of showing you how to use the power property, because you're going to need to know how to do that in your homework. How do you like today compared to yesterday? You like it better? Me too. Me too. Maybe. All right. Homework today is going to be page 473, 7 through 20 all.